Science 10, Mr. Thompson here again. Looking at 2.2 on potential energy. Okay, so potential energy. That's a form of stored energy. Potential energy is the ability to transform that energy into another type of energy to be used at a later time. Such as if you lift an object and then you drop it down onto something else. It's going to pick up speed as it falls and eventually do work on crushing whatever's down below. How about gravitational potential energy? That's one of the ones we study here. We also study elastic potential energy, but we do calculations on gravitational potential energy. That's the energy stored in an object due to its position or its height above some reference point. Now, energy is the mass times gravity constant times the height, where that constant is 9.81 meters per second squared. We also term it the acceleration due to gravity. The formula, EP equals mgh, where the potential energy is the mass of the object times the gravity constant times the height. Now the units of energy are joules. A joule can also be shown as a kilogram meter squared per second squared. So here's an example or two to follow. So a 5.0 kilogram box is lifted to a height of 2 meters. What's the gravitational potential energy? Okay, so back in B1.4, we learned that we could find that by finding the work done as the force due to gravity times the distance. And so we could do the following. The force due to gravity is m times g times d. Now I did this before, right, in a previous lesson. So you can do it this way, where you have 5.0 kilograms times 9.81 times 2.0. So a quick calculation here. Gives me 98.1 or 98 to 2 significant digits joules. Okay, but now from B 2.2, we can also use the formula EP equals mgh. And you can see that the calculation is very much the same. You have 5.0 kilograms times 9.81 times 2.0, and you still get 98 joules. All right, question number 2. Bart has a mass of 45 kilograms and he climbs a tree. If Bart has a potential energy of 800 joules, how high was the tree? So we're looking at the still. We'll do this the B2.2 style. So you put your formula down. You put in your numbers here. You have 800 for the potential energy, the mass of 45 kilograms, 9.81 for your gravity constant, times the height. So I'm going to calculate the right-hand side by multiplying 9.81 times 45, and I get the following. 800 equals 441.45 times h. So to solve for h, you're going to divide both sides by 441.45. And I get 1.8. Now I'll keep only 2 significant digits. That would be in meters. All right, now moving along here. The last part of this lesson is about elastic potential energy. Elastic potential energy is the energy that's stored in a spring or some kind of rubber band. Anything that has some extension to it where it has a restoring force, or it pulls back against it when it's extended. So when you stretch an item, it wants to push and pull back. The spring can be stretched or compressed. Notice you can stretch a spring. You can also compress it. And the examples are like a spring, elastic, a trampoline, a bungee cord. Okay? Thank you very much for joining me with that.